Hello, ELT132. This is a video regarding another method of taking a truth table and converting it into a Boolean expression. And then from that Boolean expression, you can obviously then generate a circuit. So the last video, the last one, we talked about the method called SOP. It's the sum of the products, right? SOP. Now that was done when y was equal to 1. That's what was generated, right? Now we're going to use a method called POS. And guess what this stands for? It stands for product of the sums. Okay? Please forgive my handwriting, it's not that great. So, that's what we're going to do. And let's just get rid of that and we're going to start here. So, in this time, let's see, when is y equal to 0? Well, y is equal to 0, which we're going to call y bar. That's equal to 0 when a is low, right, and b is low. Right, I'm doing this one right here. A is low, b is low, and c is high, right? Or when a is low, b is high, and c is low, right? That's this one. Yep. Then we got to come down here. Or when a is high, b is low, and c is high. Or when a is high, b is high, and c is low. Or when they're all high. What is that? A, B, C. Now I just told you it's going to be product of the sums, and what do you see here? You see sum of the products. The thing is you need to get this in terms of y and not y bar. Alright? So I'm going to pull up an expression here, or I'm sorry, the classroom presentation. And in the classroom presentation, they're going to talk to you about De Morgan's theorems. It's on page 79. Let's just write this down. What's this one? This is x plus y plus z, and there's a bar over everything. This is an OR gate with an inverted output, right? And that's equal to what? It's equal to an AND gate with inverted inputs. Do you see that? Here you have an AND gate with an inverted output, and this is equal to an OR gate with inverted inputs. These two expressions are what are used to convert what we have here. Where is it? It's right here. We want to convert this to y. Alright? So, if we go back to the presentation, this is what we have written. Okay? So the first thing they do is they negate both sides. Alright? So let's do that. So we're going to put a y bar here. This is what we have, right? I'm just copying over what we have before, right? That's A, B, C, and we have a bar and a bar, plus A, B, C, and we have a bar and a bar, right? Plus A, B, writing too fast there, C, and that has a bar, right? Plus A, B, C, that has a bar, plus A, B, C. Now, what am I going to do? I'm going to invert both sides. it. I didn't know if I was going to be able to draw that bar very straight. Do you see now what happened here? We just inverted both sides, didn't we? So y bar bar, that's like a double negative, isn't it? So this basically now has become y. I'm going to move it over here, right? I'm going to draw a little arrow over here, just so you can follow it. Now it gives us a little more room. So this essentially is equal to y, isn't it? Now what do you have here? You have 1, 2, 3, 4, 5. You have 5 inputs, don't you? Don't worry about the fact now that some are inverted or not. Don't worry about that. I'm just saying you have 5 inputs, right? You got 1 input here. You got 1 input here. You got 1 input here. 1 here. And 1 here. Okay, so you got 5 inputs. Now let's go back to the presentation and take a look at that De Morgan's theorem. So if you look at this first De Morgan's theorem right here, don't we have it in this form? We have 5 inputs instead of 3, but it's just an OR gate. Each input, whether it's X, Y, Z, or what we have, they're ORed together, and they have a bar over the entire thing. And that is equal to each input, which is inverted, right? With a bar over each input. That's exactly what we're going to do here, and that's what they show right, sorry about that, they show right here, right? So why don't we do it? We just rewrite it, okay? So this here is going to equal to A, B, C. Now, they both have bars over. That's your input, right? Now, what did I say we're going to do? If you look at this presentation, you're going to put a bar over each input, okay? So let's go back. Where are we here? So this is one input right here. And what I'm going to do is I'm going to put a little parentheses around it, all right? Now, you notice something? We're gonna AND them together, okay? So we just take each of these, we're gonna AND them. And I'm sorry, what did I tell you? I pointed to the wrong one. It's like an AND gate, right? So each one of these we're gonna invert them, we're gonna multiply them together. That's like an AND gate. That's what I meant to say, sorry about that. So let's do the next one. The next one, I'm just going to have a parentheses here. I don't need them, but I'm just doing it for clarity, okay? What do we have? A, B, C, right? A, B, C, but A and C have a bar over them, don't they? A and C have a bar. But the whole thing now is going to have a bar over it, right? Let's do the next one. What's the next one? Well, it's going to be ABC, and it's this one. It's going to have a bar over the B, right? And we're going to put a bar over that entire input. What about the fourth one? ABC. It has a bar over the C, doesn't it? Boom. There you go. And the last one is A, B, C with a bar over everything, right? You see how we came up with that now? All we did is we used De Morgan's theorems, right? These are the Boolean expressions of De Morgan's theorems. Now, if you notice, we go from here to here. What happens next? We apply De Morgan's theorem to each one of these gates, right? So what we have here basically is a gate, an AND gate with an inverted output, right? Your gate has these inputs and it has an inverted output, right? So we're going to take them and expand it to make them an OR gate with each parameter with a inverted with a bar over it. So if we do that, where are we? Right here. Let's keep going. This is going to equal what? Let's just write it down first, right? It's going to be A plus B plus C, right? Now, these have a bar over it, right? If I wrote them out, it would be A bar plus B bar plus C bar, right? But guess what? If we put a bar over each one of these, you're going to have a double bar. So those are just going to cancel out. So you're going to, you know what, I didn't even put a C there, I'm sorry. I just do this. Let's go back. A plus B plus C, we'll put this over it, and then there's your bar. Do you understand now? You're going from an AND gate to your OR gate, right? So if you're if you had these two inverted, right, you're going to have left with the other one inverted. All right. This one was completely, your output was inverted. You don't have to invert it now, right? Let's do this one. Now, this is going to be this one, isn't it? This would be inverted, right? Let's try this one. It's this one right here, right? This term. Well, in this case, A and C are going to be inverted. But B was inverted. You don't have to invert it, and you don't have to invert the output, right? There's your fourth one, right? That one is going to have your A and B inverted, right? C was inverted, so it's not inverted now. And finally, what do we have here? Well, guess what? Each one of these are going to be inverted, right? Because they weren't inverted with the gate. So look what you're left with. What do you call this? This is the product, right? Because each one of these is like a dot B. It's an AND gate between each one of these, right? It's a product of the sums. Get it? And further, take a look at it. Just look at what we're stating here. It's kind of opposite of what SOP was, right? Other than the fact that they're OR gates here, and you're ORing them together, it's a product of the sums. If you notice, these are inverted. A, B it's really A bar, B bar, C bar, like we wrote it here. But when you write this final expression, it's A, B, C bar. They're just reversed. This was A bar, B, C bar, or your second term is A, B bar, C, and so on. But this, what you have right here, is the product of the sums. Okay? So this is the method used to determine, when you're doing this in your homework, you really don't have to go through this. I wanted to go through this to explain it to you, but if you can write it out in this term, in this format, and then simply go through the changes in your, you understand that this is going to be converted to an OR gate, and the inputs are going to be inverted from what they were going into the AND gate. You can just simply write this expression down and you'll have it. I hope this has been helpful to you, and thank you very much.